Hello student, welcome back. In the previous video part 3 you have studied till what are the various transmission media, and now in this we will be covering computer network, its basic. Okay, now you see here it is what is the network? It is a group of computers connected in some fashion in order that share resources. That means when several computers are connected with each other, okay, that means from system 1 user can send or exchange information from system 3 or 2, 4 and so on, and even there is one printer P is there, so that means no need of printer on each and every separate system. So user 1 can have anything printed from common printer 1, means each one of the computer are sharing common printer. Okay, so basically network is designed for this purpose only, where the sharing of resources can take place. Basically there are three types of network. Local area network, that is limited, that is a group of computers are located in the same room or the same floor or in the same building. Okay, here the user are allowed to share storage devices, printers, application data and other network resources. Fine. Then we have wide area network. Wide area network covers relatively larger geographical area such as state, province or country. It provides a solution to companies or organizations operating from distant geographical locations who want to communicate with each other for sharing and managing central data or for general communication. Clear? Next we have WAN is made up of two or more local area network or metropolitan area network. Fine. Basically wide area network, what they use? They are connected through public networks such as telephone system, fiber optic cable or satellite links or leased line. Clear? Internet is the largest WAN in the world. Fine. For this we have also the particular organization, they provide by internet service provider which connects the LAN of the organization to the internet. Okay. Next we have metropolitan area network. Metropolitan area network is network that connects two or more communicating devices or networks in a single network that has geographical area larger than that covered by even a large local area network, but they are smaller than the region covered by wide area network. Basically man connect the computers or any devices at some remote places. Okay, now you can see the example of it of man is major technologies used in MAN networks are asynchronous transfer mode, that is ATM, fiber distributed data interface FDDI and switched multi megabit data service, that is SMDC. Then we have network topologies. What are network topologies? It is the pattern of interconnection of nodes in a network, and that is called network topology. Basically topology selection is done by keeping in mind few points, that is the cost, flexibility and reliability. Cost is for a network to be cost effective, that is one should try to choose minimal installation cost. Okay, then flexibility is that as the arrangement of furniture, internal walls keeps on getting changes, so the topology selection should be such that it allows for easy reconfiguration of the network. Then we have reliability. Failure in a network can take place in two forms. Firstly, an individual node can malfunction. This is not nearly as serious as the second type of fault where the network itself fails to operate. So the topology which is selected or chosen for the network can help by allowing the location of the fault to be detected and provide some means of isolating it. Clear? Next is point-to-point link. Before we talk about topologies in detail, let us learn about point-to-point link. To understand this, refer to this figure, which means that it relies upon two functions, transmit and receive. The main characteristics of PP network, PP means point to point, is that each station receives exactly from one transmitter and each transmitter transmits to exactly one receiver. Okay. Next we have the transmit and receive operation can occur over separate wires for better performance, or they can take turn over the same wire using a variety of techniques. Okay. Now point-to-point networks can grow in several ways. One method is simply to install a PP link between each pair of computers In the network, this approach is called a mesh. Many topologies have been developed, but major ones are star topology, ring or circular topology, and the graph. Then we have the bus, tree, and mesh. Okay. So next is star topology. Star topology is what? In this type of topology, it consists of central node to which all other nodes are connected by a single path. It is the topology used in most existing information network involving data processing or voice communication. The most common example of this is IBM 370 installation. In this case, multiple 3270 terminals are connected to either a host system or a terminal controller. Now, advantages of star topology is what? Ease of service. The star topology has a number of concentration points where the connections are joined. These provide easy access for service or reconfiguration of the network. One device per connection means the connection points in any network are inherently prone to failure. In the star topology, failure of a single connection typically involves disconnecting one node from an otherwise fully functional network. Okay, you can see this configuration. Then we have centralized control problem diagnosis. The fact that the central node is connected directly to every node in the network means the faults are easily detected and isolated. It is a simple matter to disconnect failing nodes from the system. That is, detection of failure is easy in this. Then simple access protocols. Any given connection in a star network involves only the central node. In this situation, contention port who has control of the medium for the transmission purpose is easily solved. Now, what are the disadvantages? Long cable network. Because each node is directly connected to the center, the star topology necessitates a large quantity of cable. Difficult to expand. The addition of a new node in star topology involves the connection all the way to the central node. Then we have central node dependency. If the central node in a star network fails, the entire network is rendered inoperable. This introduces heavy reliability and redundancy constraint on this node. Okay. Then star topology has found extensive application in areas where intelligence in the network is concentrated at the central node. Then we have the bus or linear topology. Another popular one is the bus and linear topology. This consists of a single length of the transmission media, normally coded cable. Okay, now in this topology is used in traditional data communication network where the host at one end of the bus communicates with several terminals attached along its length, and the transmission from any station travels the length of the bus in both directions. Okay, you can see here a common line is there, and alternatively these are connected. Fine, and there is one main server that provides the information. Advantages are it is resilient architecture. The linear architecture has an inherent simplicity that makes it very reliable from a hardware point of view. Then it is easy to extend. Additional nodes can be connected to an existing bus network at any point, but its disadvantages are fault diagnosis is built. Okay, that is, although simplicity is there in the bus topology, but there is very little to go wrong. Fault detection is not a simple matter. Then fault isolation is difficult. In the star topology, a defective node cannot be kept separated, or it cannot be separated or isolated from the network by removing its connection at the center. If a node is faulty, then what happens? It must be rectified at the point where the node is connected to the network. Then we have repeater configuration. When bus type network has its backbone extended using repeaters, reconfiguration may be necessary. Then nodes must be intelligent. Each node on the network is directly connected to the central bus. This means that some way of deciding who can use the network at any given time must be performed in each node. Next, in part 5, we will be covering ring or circular topology. Thank you.